Good day, everyone. I'm pleased to present our topic on enhancing the performance of home Wi-Fi networks using quality of service or QoS. Home networks, also known as home area networks (HAN), facilitate communication between multiple devices within a home. The router acts as a traffic controller, receiving and translating internet traffic to Wi-Fi. However, with increased device usage and higher bandwidth demands, maintaining a stable and fast internet connection becomes challenging. Implementing QoS on routers can significantly improve network performance and user experience by prioritizing critical applications. Home Wisconsin Fi networks often struggle to keep up with daily internet usage. With multiple devices streaming videos, playing online games and downloading large files, the internet connection can become slow and unreliable. This results in frustrating delays and buffering issues, especially for activities that require a stable and fast connection. The objectives of implementing QoS are to enhance the performance of the home Wi-Fi network, prioritize traffic for critical applications such as video conferencing and online gaming, and reduce network congestion to ensure a consistent online experience for essential applications. The scope of this project includes analyzing the types of devices connected to the network and the traffic they generate, identifying the QoS capabilities of the D-Link DR842C2 router, implementing QoS rules to prioritize bandwidth for essential applications, and testing the effectiveness of QoS before and after implementation. By implementing QoS, we expect to reduce slow connections and buffering during online gaming and video conferencing, achieve smoother streaming of high-definition content, and improve responsiveness for web browsing and other internet applications. To begin, we analyzed the types of devices connected to the network, the router's capabilities, the current connection speed, and the types of internet traffic generated. This D-Link router, model number DR842C2, has a material number of 10003524, a serial number of RGX842DL18120194448, a MAC Idaho of 00AD24533 and an IP address of 192.168.168. The router manages and prioritizes network traffic by allocating bandwidth efficiently, categorizing and assigning different priority levels to client devices, thus managing network congestion and enhancing the performance of critical applications like online gaming and video conferencing. At 0147 hours, the download speed was 53.48 Mbps, upload speed was 48.57 Mbps, ping was 61.07 milliseconds, and jitter was 56.51 milliseconds. At 0938 hours, the download speed was 56.87 Mbps, upload speed was 46.49 Mbps, ping was 82.91 milliseconds, and jitter was 65.03 milliseconds. At 1219 hours, the download speed was 44.68 Mbps, upload speed was 33.59 Mbps. At 2006 hours, the download speed was 42.94 Mbps, upload speed was 30.17 Mbps, ping was 71.93 milliseconds, and jitter was 22.26 milliseconds. The router handles various types of traffic including video and music streaming, online gaming, web browsing, video conferencing, file downloads, sending emails and uploading images. This analysis helped us understand the network's requirements and the areas where QoS could be most effective. To configure QoS, start by accessing the router's web interface. Open a web browser, enter the router's IP address 192.168.0.1 in the address bar, and press Enter. Log in with your username and password. The default username is admin, and the default password is either admin or left blank. Next, navigate to VLAN priority settings. Click on the Settings tab at the top of the page, select Internet from the side menu, and choose VLAN under Internet Settings. Enable triple play by setting the status to enabled, set the service provider to TM Unify, and ensure the priority Idaho is enabled. Configure the VLAN IDs and priority IDs as shown: Internet VLAN ID 500 priority ID 0, IPTV VLAN ID 600 priority ID 1, and VoIP VLAN ID 400 priority ID 2. Verify the one connection settings for each interface. Now, configure the QoS settings. Click on the Advanced tab, select QoS Engine from the Advanced settings, and enter the uplink and downlink speeds according to your internet plan. assign priority levels to connected devices by dragging and dropping the device cards into the appropriate priority boxes. For example, set the highest priority to TVT 192.168.0.109, high priority to desktop 1 QoS 192.168.0.139, and Oppo 93 192.168.168.0.168.0.151, and medium priority to the remaining devices. After configuring QoS, we conducted several tests to measure its effectiveness. We performed speed tests before and after setting the device priority to medium, high, and highest. The results showed noticeable improvements in connection speed and stability, confirming that the QoS settings were effective in prioritizing critical applications and managing network traffic efficiently. Here is speed test before any configuration. Next is testing QoS engine setting to medium. Here is speed test after set the device to medium. Next is the testing QoS engine setting to high. Here is the speed test after set the device to high. Next is the testing QoS engine setting to highest. Here is the speed test after set the device to highest. In conclusion, implementing QoS on the D-Link DA 842C2 router significantly enhances the performance of a home Wi-Fi network by effectively managing and prioritizing network traffic. This ensures that critical applications such as video conferencing and online gaming receive the necessary bandwidth, reducing network congestion and improving the overall user experience. By setting appropriate VLAN IDs and prioritizing devices, users can achieve smoother streaming, faster web browsing, and a more reliable internet connection for essential activities, addressing common issues of slow connections and buffering. Thank you for your attention.